Welcome back to the GCSEMathsPro YouTube channel. In today's video, we'll be going through my predicted paper 3H, which is based on higher tier Edexcel past papers. I have seen what's in paper 1 and paper 2, so what's on this paper 3 is basically a few of the topics that are left over and haven't been asked yet. As you can see in the disclaimer, please do not use this paper as your only revision. Please do not use it as a list of the only topics that will come up, because I obviously don't know what's actually going to come up. Please make sure you use it alongside a wider revision of the maths syllabus and don't just rely on this or anyone else's predicted paper for your final exam. You can also check out my predicted papers 1 and 2 for any topics that maybe didn't actually come up in paper 1 and paper 2, and you can revise those further from there as well. They will be linked in the description of this video. So question 1, the scatter diagram shows information about the maximum daily temperature and the number of ice creams sold in a cafe over a 2-week period. One of the points is an outlier. Write down the coordinates of this point. An outlier is obviously this one here, the one that is very obviously not part of the trend. So if we have a look, be careful of the scale, because actually this is 2 squares per degree, isn't it? So that'd be 25. 27, I'd say 27 on the x. And then on the y-axis, it's a different scale. That's just 4. So 27, 4. Part B, on another day in the cafe, the maximum temperature was 22 degrees. Estimate the number of ice creams that were sold on this day. So let's go back. This is the one where we need to draw a line of best fit. So I'm going to roughly draw one more or less throughout the middle, try and get as many points above the line as are below the line. Obviously, also you can ignore the outlier. Maybe something a little bit like this. Obviously, everyone's line of best fit will look slightly different. So as long as you get something roughly similar to my answer, then that's fine. So the question says 22. Again, remember the scale. It's 2 squares per degree. So that would be 4 squares along from 20. So I've drawn a line up and then I'll go across. I would say on my version, that's about 31 ice creams. So I'm going to write 31. However, anything kind of late 20s, early 30s would be fine for that one. Question 2. Omar wants to invest £12,000 for 4 years in a bank. We've got 2 options here. We've got Broadview Bank, which is compound interest at 1.9% for each year. Then we've got Redwood Bank, which is also compound interest, but it's 3.7% for the first 2 years and then 0.6% for each extra year. Which bank will give Omar the most interest at the end of 4 years? So we just need to work out both separately. So the first one, Broadview, you can obviously use your compound interest formula from the formula sheet. The way that I write it is obviously the starting amount, so the 12,000 he wants to invest, multiplied by 1 plus this percentage over 100, which as a multiplier, as a decimal, is 1.019. That's how I like to write it. You might prefer to just put 1 plus 1.9 over 100 in the brackets. That's absolutely fine as well, whichever version. And then to the power of how many years, which would be 4, because it is just the same every year. As you can see, that gives me 12,938.32. Now let's work out the amount for Redwood. So this one is 12,000 again, starting with. For the first 2 years, we've got 1 plus 3.7 over 100, so 1.037. But as I said, 2 years, so that's squared. Now you can work this out in 2 steps or just in 1. I'm just going to do it in 1. And then also we've got times 1 plus 0.6% over 100. Just be careful with this. This would be a double 0 there, wouldn't it? And again, for the other 2 years to make 4 years in total, which, as you can see, gives me £13,059.75. So which bank gave Omar the most interest? Well, obviously, both of these values do include the original 12,000, but because it was the same starting value, we can just compare which one has the biggest end value. So obviously, therefore, Redwood is the bank that I would choose, because that one obviously gives me more interest. That one's about £1,000 interest, this one's about 900. And that's for 3 marks. Question 3, the height of a building is 10.3 meters, correct to the nearest 0.1 meter. Complete the error interval for the height of the building. Now, because this one is correct to something, it's basically rounded, isn't it? So this is the example where it is exactly the same as upper and lower bounds. So the smallest one would be 10.25. Now they have left it blank, so we need to write the interval, as in the inequalities. So the smallest number is always less than or equal to. Now I'm just going to put h for the height. And then the second inequality is then just less than 10.35, because it can't be exactly equal to 10.35, because technically that would round up to 10.4, wouldn't it? So it's anything slightly less than 10.35, hence why less than and not equal to. Question 4, the table shows information about the heights of 60 tomato plants. So we've got a frequency table here. Find the class interval that contains the median. So the median is the middle number. Because there are 60 plants, we're looking for the 30th tomato plant. So imagine that these are all listed in order. The first row includes the first 9 plants, so that's not enough. If I then add on the second row, that goes from plant number 10 up to plant number 33. So that starts at plant number 10 up to 33. So yes, it would be in this second row here. 140, H, 150. So part B, we do need to draw a frequency polygon for the information in the table. So when it's a frequency polygon, not to be mixed up with cumulative frequency, this is where you work out the midpoint of all of the rows. So for the first one, the midpoint would be 135, and then we'd go up to 9. The second one would be 145 up to 24, then 155 up to 17, 165 up to 8, and 175 to 2. Now we just join it up with straight lines, and here is our frequency polygon. So use the midpoints, do not join it up into an actual polygon, just leave it open as a graph. Question 5, Thomas has some marbles. He only has red marbles, orange marbles, and blue marbles. The ratio of the number of red marbles to the number of orange marbles is 3 to 8. The ratio of the number of orange marbles to the number of blue marbles is 6 to 7. Thomas has less than 150 marbles. What is the greatest possible number of blue marbles Thomas has? So I've got two ratios separately, but they overlap because they both have orange marbles. So I'm going to want to create a 3-part ratio. So I've got red, orange, and blue. Red to orange is 3 to 8, but then orange to blue is 6 to 7. So can you see how the overlap is 6 and 8? I need to find the lowest common multiple of 6 and 8, and then change both ratios to create that same scale. Lowest common multiple would be 24. So do you see how the first one, the first ratio, I would have to multiply to get from 8 to 24 by 3, and the second one to get from 6 to 24 by 4. So my 3-part ratio would be 9, obviously 24, and then 28. Now, if I add that up, I can find the number of parts of the ratio for all 3 marbles, which is 61. And then I can move on to the fact that Thomas has less than 150 marbles. So how many times does 61 go into 150? If I divide that, obviously it's not a whole number, but you can see it goes in twice fully, and then there's a remainder as a decimal. So twice fully. So if he has less than 150 marbles, it's not that he has exactly that many, just less. So I know I can only fit 2 lots of 61 in. So therefore, I would have 122 marbles. Technically, if I wanted to find out any of the numbers of marbles, I'd multiply each of these by 2. I've only been asked to find blue though, so blue is obviously the 28 parts. I can only have it twice, so that gives me 56. 56 blue marbles. Question 6. The diagram shows a circle sector with radius 45 centimeters and center O. It also shows a square and a semicircle. CO is the diameter of the semicircle. The radius of sector AOB to the radius of the semicircle is 3 to 1. Zainab says that the shaded region is exactly 1/3 of the area of the sector AOB. Is Zainab correct? So effectively we're just working out a load of areas, aren't we? We want the area of the whole sector. You could always start there. So the area of the sector. Now, they've not given us an angle explicitly, but we do have this square, and obviously a square we know is 90 degrees. So we know it's effectively a quarter of a whole circle, isn't it? 90 degrees. And we know that the radius, so we've got pi r squared, the radius is 45, so 45 squared, but I only want a quarter of that. Now, obviously that's a load of decimals, so I'm going to leave it, even though it's still kind of annoying, in pi format just for now. So 2025 over 4 pi. Just so that I have the exact area and I can come back to that later. Okay, how do I work out the area of the shaded region? Well, I would obviously also need the area of the square. The only thing is, currently I don't have any measurements for the square. I know that the whole of OB and OA is 15, so let's come back to our ratio. The radius of the sector, so let's say OB, to the radius of the semicircle, and they have said radius, it's not CO, it's kind of like here, halfway, isn't it, is 3 to 1. So if I know that obviously I've got, 3 to 1, I know that this side is 45 because that is the radius of the sector, then I would just divide by 3, wouldn't I? And obviously technically times by 1, but that makes no difference. So 15. So this is 15. Technically, therefore, the whole diameter of the semicircle would be 30, and obviously we know that the whole radius of the whole sector is 45. So in terms of the square, it's going to be 30 times 30, isn't it? Which is 900. And finally, I do need to know the area of the semicircle to subtract it to find my shaded region. So the area of the semicircle is obviously pi times the radius, which we worked out as 15, squared, but over 2 because it is only half of a circle, isn't it? And again, as you can see, loads of decimals, so I will leave it in this format of pi, so 225 over 2 pi. Okay, now we've worked out all of these areas. I want to know the area of the shaded region too, which is the whole square minus the semicircle. So I get 546.57 ... Now I want to know, is that area exactly 1/3 of the area of the sector? So let's divide it by the area of the sector, which I've still got the exact value for. So I'm just going to take my answer and divide it straight. And this is what I get. I get 0.3436 ... So we have to figure out, is that exactly 1/3? Well, either hopefully you know what 1/3 is as a decimal anyway. Obviously, if you don't, you can just work it out. As you can see, is 0.333. So is it exactly 1/3? Well, no. So I need to say, they said, is Zainab correct? Well, no. Because it's actually bigger than 1/3. It's not exactly the same, is it? And that one, as you can see, was 4 marks. Question 7. On Monday, 60 machines took 6 hours to produce 1,000 parts. On Tuesday, only 12 machines were used to produce 1,000 parts. Assuming that all the machines produce parts at the same rate, work out how many hours the 12 machines took to produce all of the parts. So this is inverse proportion, because think about it, if I've got more machines, it's going to take me less time. If I have fewer machines, it's going to take me more time. I first want to work out how long would it take for, in this context, one machine. Now you might think, oh, I just need to divide 6 by 16. No, that would be if it was directly proportional. It's not. It's inverse, isn't it? Think about it. If I have one machine, it's going to take me 16 times longer. So 6 hours times 16, which gives me 96 hours. And then obviously to scale it back to my 12 machines, if you think about it, 12 machines is going to take less than 96 hours, isn't it? It's going to be 12 times faster. So divide that by 12, and you get 8 hours. So for these questions, you always multiply first, then you divide. Part B, it says that the assumption is actually wrong. How might this affect the time taken for the 12 machines to produce all the parts? So what was the assumption? It was that all the machines produce parts at the same rate. If this is wrong, if they don't produce parts at the same rate, how would this affect my answer? Well, we don't really know what specifically is happening to the rates. So it could be, my answer could be more time or less time. It just depends. I actually don't know, because they're saying it's not the same rate, but I don't know if most of them are, maybe if some of them are slower or if some of them are faster. I don't know that detail. So it could be more or it could be less. Either way, your answer will be different, basically, won't it? So question 8, here is the graph of y equals x squared minus 2x plus 3. Use the graph to find estimates for the solutions of the equation. X squared minus 2x plus 3 is equal to 5. Now pay attention to this. The original equation, which is the graph, is the same as this left-hand side here. I know it swapped sides, but that doesn't really make any difference. And before, the original equation had a y on the other side. Now the y has become a 5. So what that tells me is I'm looking for where y is 5. Normally if that's equal to 0, you'd look on the x-axis because that is where y is 0. But sometimes they can actually give you a number that's not 0. It's the same logic, but obviously I'm not looking at the x-axis anymore. I'm looking at another horizontal line where y is 5. We don't need to rearrange anything here. It's just literally using the graph. So I'm going to draw a line across at 5. So that would be 5. And then do you see where it crosses twice? So that's why I've got 2 solutions still. We only need to find out the x solutions because the equation technically only has x in it. And also, we kind of know that y is 5 anyway. So for my first solution, be careful of the scale of the graph. This is obviously here minus 1. So I think that that's about minus 0.75. Now, normally to 1 decimal place is fine. So if you said something either negative 0.7 or negative 0.8, anything between those or either of those would be fine. And then the other one normally is kind of symmetrical with the decimal. So here, this is technically 3. So that's probably 2.75, just to match my other answer. And again, if you chose anything from 2.7 to 2.8, that would be fine. So that's all I need to write. As you can see, they've barely given me any space for working out because there technically isn't any. Question 9. There are only purple buttons, green buttons, and yellow buttons in a box. The ratio of the number of purple buttons to the number of green buttons is 5 to 8. Sophie takes at random a button from the box. The probability that the button is yellow is 0.35. Work out the probability that Sophie takes a green button. Okay, so if we've only got purple, green, and yellow, that means that those probabilities should all add up to 1. We know the probability of yellow, so let's subtract that first. Let's get rid of that. So 1 minus 0.35 leaves me with 0.65. So that is the probability of the other two, purple and green. And I've also got a ratio to share out purple and green. If you prefer to make this into, let's say, 65 as a percentage, for example, to share out the ratio, that's also fine. I'm just going to leave it as a decimal. So to share out a ratio, we add them up. So that's 13. 0.65 divided by 13 parts of my ratio is 0.05. So that's the probability per part of my ratio. I just want to know green. Green is the one with 8 parts. So I'm going to multiply by 8. As you can see, that gives me 0.4. If you put it as 40%, that's also fine. If you put it as a fraction, 2 over 5, also fine. Percentage, fraction, decimal is fine for probability. It doesn't matter which. I've just left mine as a decimal because the question was in decimals. So question 10, the accurate scale drawing shows the positions of hiker A and hiker B. The scale you can see is 1 centimetre, so on your actual, whatever you printed it out as, 1 centimetre represents 3 kilometres. Hiker A walks at a speed of 4.5 kilometres per hour on a bearing of 110 degrees for 3.5 hours to campsite C. Find the distance in kilometres of campsite C from hiker B. So we need to find out where campsite C is first. I would start by drawing the bearing. So because it's on a bearing of 110 from the hiker, it's going to be from this north line and then clockwise. So you're going to line up your protractor with the A north line. So I don't have an actual digital protractor, but I've just copied this one here just to show you how to line it up. So on the north line with A, obviously A is the centre. So you can see I've lined up the centre of my protractor with the A point, and then the 0 line, which I'm reading these black ones on the outside, the black numbers, the 0 line with the north line. So I want to go to 110. So that would be about here. So grab your pen or your pencil, you can just roughly mark that. That's about 110 there. Then you can draw a line that goes through that and maybe extend it a bit further because we haven't tested the distance yet. So campsite C is somewhere along this line. Now I need to figure out, well, how far along the line. So we've got speed, distance, time. If I use my formula triangle, I want to find out the distance. So that's speed times time, which was 4.5 kilometers per hour multiplied by 3.5 hours, which, as you can see, gives me 15.75 kilometers. Now to convert that into centimeters so that I can measure it on my scale drawing, I just need to divide by 3 kilometers to tell me how many centimeters that is. So 5.25 centimeters is how many I actually need to measure with my ruler. So along from A, 5.25 centimeters is actually about here. Yours might look different because obviously the scale on my computer versus the scale that you've printed it out as. Just work with the scale that you've printed it in. That's where campsite C is. Now, the actual question was find the distance in kilometers of campsite C from hiker B. So now if I draw a line from C to B, and then you would measure that with your ruler. Now mine says 3.1 centimeters. So 3.1 centimeters, I want to know obviously in kilometers, so use the scale again. I need to multiply by 3 this time, which gives me 9.3 kilometers. Now, as I said, you might get a different answer depending on how big your version of the page is. So as long as you follow these steps, then that's absolutely fine if you get a different answer to me, as long as you've measured out the 5.25 correctly, and then whatever you've got as a distance between C and B, times it by 3, then yes, you will have done it correctly. So 9.3 kilometers for my answer. Question 11. A is the point with coordinates 2D. B is the point with coordinates -4, -2. The gradient of the line perpendicular to AB is -4/3. Work out the value of D. So I could work out the gradient of AB. Because it's perpendicular, that means it's the negative reciprocal. So negative as in change the symbol, it's already negative, so that would become positive. Reciprocal is where you flip the fraction upside down. So I've got 3/4. Now, can I set up an equation to find the gradient of AB? If I were to go and find it, I would do change in y over the change in x, which is the same as d subtract -2 over 2 subtract -4. Now, you can put them the other way around, the -2 and -4 first, the d and the 2 second, that's also fine. As long as you vertically match them up in their coordinates, then that's fine. It doesn't matter which one goes first and which goes second. And that is the equivalent of 3/4, isn't it? That's my equation. So now I'll just solve the equation. I've got d plus 2 because double negative, same here. 2 plus 4 is 6. That equals 3/4. Now I'm going to cross multiply just to get rid of the denominators all in one step. So multiply across by 6, multiply across by 4. So I get 4d plus 8 is equal to 18. And then you can just solve it from there, can't you? So 4d would be equal to 10, and therefore d would be 2.5, or 5 over 2 is also fine if you want to leave it as a fraction. 2.5 for d. And that is 4 marks. Question 12. A pet shop owner asks 50 customers whether they have a dog or a cat or a hamster. We've obviously got some information about the customers, which I'll read in a second, but we basically need to, for part A, complete the Venn diagram. So of these customers, 3 have all 3 pets, so that goes obviously then in the middle. You can tick them off as you go. 5 do not have any dogs, cats or hamsters, so that's on the outside. None at all. 12 have both a dog and a cat, but not a hamster, so that would be just this section here, 12. 6 have a cat and hamster. Now, be careful of this. Do you see how the previous one mentioned they have a dog and a cat, but they do not have a hamster? The next one mentions a cat and hamster. It doesn't say that they don't have a dog though, right? So that's not just this section here. They could still have a dog. So I think what that's referring to is these 2 sections, because they have not specified that they don't have any dogs. So this must add up to 6, which means the missing part is just 3. So just be aware of that when you get this question. Have they mentioned this and not the third, or just this and this? And then 30 in total have a dog, so that means the whole dog bubble, the whole dog circle is 30, but I'm missing 2 pieces, so I can't really do anything with that just for now. And finally, all 10 who have hamsters also have either a dog or a cat, which means there's 0 here for just hamster. And then all of this, these 3 here, must add up to 10. So I can fill that in. This would be 4, and then I can go back to the 30 that have a dog. So if you take these 3 away from 30, you get 11, only dogs. And the last one though, and even though we've ticked everything off, we do still have one gap, which is cats only. So go back and check. They must, obviously the Venn diagram must add up to 50 in total. So take away all of the other numbers, we get 12, which are just cats. So that's 4 marks for part A. We do also have a part B here. So one of the customers is chosen at random. Given that this customer has a dog, find the probability that this customer also has a hamster. So we're saying, given that they have a dog, so we're just kind of zeroing in on this circle here. We're no longer looking at the whole Venn diagram, just this circle, which you can add it up, but technically we know that makes 30, doesn't it? Because it's said in the question. So it's actually out of 30, not out of the whole 50. How many also have a hamster? That would be these 2 here. So that would just be 7. 7 out of 30. which gives you 2 marks, obviously 1 mark for the numerator, 1 mark for the denominator. Question 13, show that 2x squared minus 50 over 2x plus 4 divided by x minus 5 and then subtract 2 on the outside simplifies to a plus bx over cx plus d, where a, b, c and d are integers. So we're just simplifying algebraic fractions here. I like to try and factorise if anything is possible to be factorised. Basically it's just this first fraction, isn't it? I can first pull out 2 and I get x minus 25. I can also pull out 2 in the denominator, x plus 2. So even before you start, you can already cancel the 2's. Divided by, now let's write this as a fraction. Anything you want to write as a fraction that's not already a fraction, just put it over 1. Minus 2, don't forget the minus 2 there. Now, can I factorise this further? Actually, I can, because that is difference of 2 squares. It will pop up somewhere in your exam, so watch out for it. You've got x plus 5, x minus 5 over x plus 2 still. Now let's do keep flip change, so keeping the first one, flipping the last one, which is why I made it into a fraction. 1 over x minus 5 and then change it to a multiply. Minus 2. You can see here when I multiply, I'm going to multiply straight across and you should be able to then cancel out the x minus 5's. So the last thing I need to do then is actually be able to subtract 2 from the fraction. Now you can only add and subtract fractions if they have the same denominator. So first of all, we need a denominator for 2. As I said, anything that's not already a fraction you can put over 1. Now how do I get from 1 to x plus 2? That would be my common denominator, wouldn't it? Just multiply the second fraction by x plus 2. So you've got minus 2 brackets x plus 2 over x plus 2, because obviously if I were to simplify this I would just cancel both of those out and it would go back to being 2. Now you can obviously expand and subtract the numerators, so we've got x plus 5 minus 2x. Be careful because technically it's minus 2, so you're doing minus 2x minus 4 as well. Don't mix up that negative there. Over just x plus 2, collect the like terms. So you can see we get 1 minus x over x plus 2. Which does match the format they've asked for, doesn't it? Let's have a look. They said something plus, I know it says plus. Whenever it says plus, it doesn't necessarily mean it's not a negative, right? It's just that, let's say in this case, b is negative 1, isn't it? If I go down again, a would be 1, b is then negative 1 because they haven't accounted for the negative themselves. C is 1 and d is 2. Technically, those are your integers. And that's for 4 marks. Question 14. Neve wants to work out an estimate for the total number of frogs in a pond. On Wednesday, Neve catches 15 frogs from the pond. She puts a tag on each of these frogs and puts them back into the pond. On Thursday, Neve catches 24 frogs from the same pond. She finds that 9 of the 24 frogs are tagged. Work out an estimate for the total number of frogs in the pond. So, normally the way I do this is you just basically have to memorize a formula. Whatever version of the formula you want to memorize, it's up to you. But from what I've seen, these questions are asked in the exact same format every time. So it's just the first 2 numbers that you come across multiplied, 15 times 24, and then you divide by that third number. That's how I do it. You might want to memorize the formula in a different way, that's absolutely fine. But as long as you get the same answer of 40 at the end, then you know you're on the right lines. So the estimate is that there are 40 frogs, that's 3 marks. Now part B, write down one assumption that Neve made. In this context, you've got related to the context, she tagged the frogs. So our assumption is that none of the tags fell off or came off or whatever it was. You could say fell off or came off, because technically they could if you know, I don't really know how well you can tag a frog. Technically they could lose their tags, couldn't they? Sometimes if they say that the animals or the insects or whatever have been marked, that none of the marks have come off or the marks have rubbed off, that kind of thing. Because obviously that would affect then the number 9, which obviously if you change the number 9, it affects your overall answer, doesn't it? Something to do with the tags. Question 15, make g the subject of the formula. K is equal to g plus 3 over 5 minus 2g. So this is a harder rearranging one because the letter that I want to make the subject appears twice. But the good thing is there's a very consistent method of how to work this out. So obviously I don't want to have the fraction. So first of all, I'm just going to multiply by that denominator. So that would give me, I'm just going to expand it at the same time. 5k minus 2g k is g plus 3. So I've opened everything up. You then want to get all of the terms that have that letter on the same side, so the 2gk and the g, and then anything else on the other side. So I'm going to add 2gk, and at the same time I'm going to subtract the 3 because that's not related to the g at all. I've just moved it to the right just because that would make them both positive. You can technically move them both to the left if you want. I just prefer personally to avoid any negatives where I can. Now, you might be thinking, well, how do I get the g's together? Because they're not currently like terms. This is a g, this has got a k with it. This is the bit you have to memorize. To get them to just become one g, you factorize out the g's. So I factorize it out, I get 1 plus 2k, and now I've got a singular g on its own. And hopefully you can see what the final step is. Just divide across by that bracket. So 5k minus 3 over 1 plus 2k. And now g is the subject. So just remember that, get them all on the same side, factorize, divide. It's basically the same process every time. Question 16, here are the first 5 terms of a quadratic sequence, 1, 10, 25, 46, 73. Find an expression in terms of n for the nth term of this sequence. So I have a very specific method that I like to follow. You might have a different method. It's absolutely fine. Stick with whichever method works for you. So first of all, I find the first difference, the first row of differences. So 9, 15, 21, and 27. Obviously, they're not the same because it's a quadratic sequence. So then I find the second row of differences, which is 6, 6, and 6. These obviously should be the same. The way that I do it is that I memorize 3 equations. First, 2a is always equal to that second difference. And then you can just solve that to find a. So obviously divide by 2, so a is 3. Then the next one is that I memorize 3a plus b is equal to the first difference, but the first one in that row. So on the left-hand side we're working with. So that's 9. Now, because I do know what a is, I can substitute that in as well. And do you see how I could then work out what b is? So in that case, b is just 0. That's fine. You might end up with b or c becoming 0, which just means it's not there. And finally, the last equation I memorize is a plus b plus c is equal to the first term in the actual sequence. So in this case, 1. And because I now know a and b, that's 3 plus 0 plus c is 1. Obviously, then you can solve that. So I get minus 2. Now, what do a, b, and c represent? Well, that's the format that we would write our answer in. an squared plus bn plus c. So in this case, we've got 3n squared. Because b is 0, we just don't have the bn, the middle term, which is fine. So don't write that. And then we have minus 2 at the end. So 3n squared minus 2 is the nth term of this sequence. Question 17. The area of triangle ABC is 55 centimeters squared. We've been told that AB to BC is 2 to 5. Work out the side length BC. So obviously the formula is the area of the triangle, but specifically the trigonometric version, because I don't have perpendicular height, I also don't have the base. So we're going to be using the trigonometric version, which is obviously on your formula sheet, but it is half AB sine C. Now, if you need to scribble out the angles or the letters and change it to match your formula, that's also fine. You could swap this and this if you like. Obviously then, this is side A, this is side B. Now, I don't technically have a side A or side B, but I have this ratio here. So what I would probably do is just chuck an x in, because I don't know, let's say 2x is obviously, AB is obviously a multiple of 2 because it's 2 parts. BC is a multiple of 5 because it's 5 parts, but we need to know what x is. So I would probably label this one as 2x, this one as 5x, and then substitute it in like that. So I know that the area is 55 centimeters squared. I've got a half 2x multiplied by 5x sine of 86. And then I'll just solve it from there to get x. So this side, obviously, you get 2 times 5, which is 10, times a half is 5. So 5x squared sine 86, and that's when I'll put it in the calculator, is 55. So if I want to move over the 5, obviously I've got 55. So you can do it in one step or two, but 55 divided by 5 is obviously 11. 11 divided by sine 86 is 11.0268, loads of decimals. So that's x squared. I might write that down. Obviously, then I want to square root as well. So I've got roughly 3.32. For x, 3.32. Now, just remember though that that wasn't the final answer. They asked for the side BC. Remember that BC is our side with 5x. Obviously, if you do change the letters, make sure you know which one was the original. So BC is 5 times the 3.32. So take my answer, so at least I've got all the decimals, times it by 5. Now I'm going to round it. It says 3 significant figures, so 16.6 for BC. So there's your answer. And as you can see, that will give you 4 marks. Question 18. Solve algebraically the simultaneous equations y equals x squared plus x minus 6 and 4 is equal to 2x minus y. So obviously we've got one quadratic and one linear. So when you've got this scenario, you always have to take the linear one, substitute it into the quadratic. But sometimes you'll have to rearrange the linear one to get either x or y as the subject. It doesn't really matter which, but normally I would just check maybe which one's easier to rearrange or which one's easier to substitute in. Because I've got x squared and x, I think I'd rather substitute in for y because it's only appearing once and it's not squared. So I'm going to rearrange this to get y as my subject. So obviously I would need to add y. You can obviously do this in one step if you like, and then take away the 4. So y is 2x minus 4. If y is equal to 2x minus 4 and is equal to x squared plus x minus 6, then I can just make those equal to each other. That's my substitution, isn't it? Is equal to 2x minus 4. Now, because I'm obviously going to end up with a quadratic anyway, I need to get everything on one side. I tend to choose the side of the equation where the x squared remains positive. So in this case, I'm going to move everything from the right to the left. So subtract 2x gives me negative x, and then add 4 gives me negative 2. Now you can either solve this by using the quadratic formula, because you do have your calculators, or you can just factorize it, because it does look like it's going to be factorized. So I just factorized it, 1 and 2, minus 2 plus 1, and then I'm going to solve it. Obviously, because it's a quadratic, we're going to get 2 solutions, so I got minus 1. This was the hardest bit, wasn't it? So all you need to do now is find y. And what I would do is sub it into, first of all, the linear equation because it's easier. Second of all, the rearranged version of the linear equation because you see how y is still the subject. So 2 times minus 1 minus 4 gives me minus 6. Or, do the other one, 2 times 2 minus 4 is just 0, isn't it? There's my 2 sets of solutions. So you can see here, normally quadratic simultaneous equations is 5 marks. So minus 1 and 2, and then y is minus 6 and 0. And there's my answers. Question 19, we've got circle theorems. So A, B, C, and D are points on the circumference of a circle centre O. CDE is a straight line. It's not a tangent, but it is a straight line, okay? So don't think that that's a tangent because it's obviously cutting through the circle, and tangents don't go through a circle, they just kind of skim the edge of it. Obviously, you can see that angle AOC is 126 degrees. Work out the size of angle ADE. So let's identify that one. That's this one first. So I can only start with 126. This one here is screaming at me, the arrow one, the one where the angle at the centre is double the angle at the circumference. So I could work out A, B, C. Now they have asked us to give reasons for our working as well. So A, B, C would be half of that, wouldn't it? The one at the circumference is half the one at the centre, or vice versa. So 63 degrees. So there's my reason. The angle at the centre is double the angle at the circumference. You can obviously write it the other way around if you want with the half. So this is 63. Then we kind of need to, I say this like zoom out in your head. Try not to look so much at each individual shape, but zoom out in your head. A, B, C, D are points on the circumference of a circle, which means it is a cyclic quadrilateral. And we know that the opposite angles in a cyclic quadrilateral add up to 180. So I can work out ADC. So 180 minus my 63 is 117. And I've written my other reason about the opposite angles in a cyclic quadrilateral. So this is 117. And finally, because they told us CDE was a straight line, I can work out ADE. So obviously 180 minus again gives me 63 again. So that's my final answer, and then because angles on a straight line obviously add up to 180, so I would suggest write down at least 2 reasons, and specifically if you can, focus obviously on the circle theorem's reasons. Those are the main ones they'll be looking for. 63, so that's probably 3 marks for the working and 1 mark for your reasons, but they would be looking, as I said, for 2 reasons for that 1 mark. Question 20, given that x squared minus 12x plus 2 can be written as or is equal to x minus a squared minus b for all values of x. Part I, find the value of a and the value of b. So hopefully you can just recognise this. The formatting is difference of 2 squares. So I'm just going to reformat it basically. So that would be x minus, I half this value, don't I, the 12, so that becomes 6 squared. Then on the outside you always subtract this number squared, technically minus 6 squared, but obviously that would become a positive anyway. And then I still have that plus 2. So all I need to do now is work out that number on the outside. Minus 6 squared, that's subtract 36 plus 2. I'm just writing a few lines of working out just so that they've got something to mark. So that's minus 34. Now, this question is slightly different to the one we looked at with algebraic fractions. They've already accounted for the negatives. You see that? Negative 6, negative 34. They've already accounted for the negatives. So for my a value, I'm just going to write 6 and b 34. Because if I wrote negative 6, negative 34, it would technically, if you were to sub it in, do you see how that would be wrong? It would be a double negative. So if they've already accounted for any negatives, you don't need to write them. If they had put plus, let's say they put plus here, then yes, I would put negatives here. But I don't need to, so get rid of that. So just double check. Have they accounted for any negatives already, or do I need to myself? That's obviously an easy 2 marks. Just going to rewrite it here so that we can see it. Now, part II, hence, so that means therefore, write down the coordinates of the turning point of the graph y equals x squared minus 12x plus 2. That's the same graph, isn't it? So the turning point is when you've completed the square, you can just have a look at this. The number next to the x is the x coordinate. However, just remember with x, we do change the symbol, so that becomes positive. The number on the outside is just as it is the y coordinate, so negative 34. So hopefully quite nice 3 marks for that question. Question 21, obviously vectors has to come up at some point. ACD is a triangle. You've got the vectors here. AD, they haven't drawn them on, so let's do it ourselves, is A. AB is B. And then BC is 8B, not drawn to scale. M is the point on DB, such that DM to MB is 3 to 1. Again, not necessarily drawn to scale, so don't assume that this is the midpoint unless they physically tell you, right? It's obviously not in this case. Technically 3, and that's technically 1. That's not a vector, right? That's just a scale. N is the point on DC, such that DN to DC is 1 to 4. Now be careful of this one though, because you see how it's DN, which is 1, but then DC, so that's the whole thing. So that includes the n. So technically this is then 3, isn't it? N to C. So just make sure you are reading any ratios they give you properly. Show that A, M, and N lie on a straight line. Okay, so this is a proof. We're proving they lie on a straight line, which means we have to, first of all, prove they're parallel. In order to prove they're parallel, we have to find them out in the first place. So choose 2 vectors from that line. Normally I would just choose the whole thing. Let me draw the line first. So for example, I would probably choose to work out A to N, just as the whole thing. And then a smaller version, you can choose A to M to N. You could choose the backwards version if you want, N to M, N to A. You get the gist. Just choose 2 of them because we want to compare them. So those are the 2 I'm going to find out. So to find out A to N, I first of all, obviously need to find out a few other vectors. I would probably go up at A and then down here. But you see how I don't know D to N? Again, 1 is not a vector, that's just the scale. So I need to find out D to C first. D to C would be minus A plus B plus the other 8B. So obviously simplify that. Minus A plus 9B. Now, I don't want the whole of DC, I just want a smaller part of it. So this is where we turn our ratios into fractions. That's obviously 1/4, isn't it, of the whole line. So for D to N, 1/4 of minus A plus 9B, which I will also expand. So that's minus 1/4 A plus 9/4 B. Now I can come back to A to N. A to N was A plus dn, so that's actually minus, isn't it? Minus 1/4 a plus 9/4 b. Obviously, again, simplify any of that you need to. So that would be 3/4 a plus 9/4 b. And then the other one I want was a to m, that's what I chose. A to m, I would obviously still probably go up to d, so that's a, and then plus, I'm coming along the db line now, so again, another vector that I need to figure out is db. That one's just negative a plus b, isn't it? And then I want actually d to m. So again, thinking of my ratios into fractions, that's 3/4 of the line. 3/4 minus a plus b. Expand. So negative 3/4 a plus 3/4 b. Now I can add that to my previous a. So negative 3/4 a plus 3/4 b. Again, simplify, collect the like terms. So that would be 1/4 a plus 3/4 b. Okay, that would get you the majority of the marks. How do I prove it's parallel? How do I prove that any two vectors are parallel? You have to show that one is a multiple of the other, one is a bigger version of the other. Obviously an, because it's physically bigger. So let me find the scale factor between a coefficients, and it should be the same scale factor between the b ones. So 3/4 divided by 1/4, you can obviously work that out with a calculator or without, is 3, isn't it? It's 3 times. Now, does that ring true for b as well? 9/4 divided by 3/4, well, yeah, is also 3. Because they have the same scale factor, they're multiples. an, we're saying, is 3 times as big as am. So you can write that down. You can write down an is 3 times as big as am if you want. The way that I would write it is an is equal, whenever you say in your head the word is, that's where you put the equal sign, 3 lots of am, isn't it? 3 lots of the smaller one. That shows that they're multiples, therefore parallel. And then the last thing is, okay, they're parallel vectors, but how do I know that they are literally together and create a straight line, rather than just floating around kind of randomly? Well, if you look at it, in my particular case, because I chose these two vectors, the letter that I have in common, which is referring to a point, is a. If they are both parallel vectors, but they start, in my case, they both start at point A, they must overlap, which means they must create a straight line, mustn't it? If you chose different two vectors, obviously from that line, you just write down whichever letter you have in common. So I would say they share point A in common, therefore that makes it not just parallel, but they lie on a straight line, they overlap each other. So it's proven they're parallel, that they are multiples, and then if they ask for a straight line, add an extra kind of sentence about whichever point they both share. If you're looking for a harder vectors question, which is on the ratio and scale, then I have got one in my paper 2 predicted paper. You can go back and have a look at that question as well. Question 22, here is the graph of y equals f of x. On the grid, sketch the graph of y equals negative f of x. So just graph transformations, you just have to memorize what they mean. Negative always means reflection, but it's on the outside, so that means it's a reflection in the x-axis because it's affecting the y coordinates. So that would stay the same. This one would go negative. You could obviously plot that one if you want to go down, up. Here, this one goes negative. This one stays the same, so I would just join that up as a curve. So just something a little bit like that. So for part B, we've got here is the graph of y equals g of x. On the grid, sketch the graph of y equals g of x minus 2 in brackets plus 1 outside the brackets. So if you've got plus or minus a number, it means some kind of translation, moving left and right, up and down. Here we've obviously got two numbers, so 2 translations. The first one is in the brackets, so that means that it is a translation on the x-axis. However, the x-axis, there's always something wrong about it, isn't there? We're not taking away 2, we're actually going to add 2, we're going to go 2 to the right. The one on the outside is always the y-axis, and that one is just how you think it would be. So yes, that would be up 1. Now you can obviously split this into 2 kind of drawings. You can draw kind of a halfway point if you want, do one of them first, then do the second. I think because they're both translations, it's not too difficult to figure out. So just choose a couple of really good coordinate points that are quite obvious. So let's start with this one here. We've got 2 to the right, 1 up, so actually that would go to there. This one that was here would go 2 to the right, 1 up here. This one crosses through as well, so 2 to the right, 1 up here. This one, let's go with 2 to the right, 1 up here. And this one does technically go off the grid, doesn't it, too, so right, and technically it's up here, but just so you've got some kind of marking to sketch it out. So again, just join it up as best you can with your pencil. So hopefully yours will look a little bit nicer than mine, but it looks something like that in the end. So we've got our final question now. Question 23, we've been given a formula. A is equal to v squared minus u squared over 2s. So v is equal to 17.8 meters per second, correct to 3 significant figures. U is 13.5 meters per second, again, correct to 3 significant figures. And s is 45 meters, correct to 3 significant figures. By considering bounds, work out the value of a to a suitable degree of accuracy, and you must give a reason for your answer. So by considering bounds, this is normally the one where you have to work out both the upper and the lower bound, and then at the end, make a decision as to what your value is going to be. So let's see. For the upper bound of a, we need to work out what combination of upper and lower bounds for v, u, and s we need to get the biggest possible value of a. So to get the biggest possible outcome, I want to have the biggest possible numerator. That would mean the upper bound of v, also don't forget that that's squared, but I would have to subtract the lower bound of u. I want to reduce it as little as possible, basically, don't I? Over, and then I want to divide by the smallest possible value, but 2 times that. So again, lower bound of s. For the lower bound of a, for the smallest possible value, it's just the complete opposite, isn't it? I want the smallest numerator, so the lower bound of v squared, take away the biggest possible number from that to reduce it even further, divided by the biggest possible denominator. So this is what I need. So let's work out our upper and lower bounds. So v, the upper bound. This one's fairly straightforward, 17.85. Lower bound, 17.75. U, very much the same, 13.55, and then lower bound, 13.45, and then s. Now this one's a little bit trickier, because I feel like naturally you want to put 45.5 and 44.5, but it's not, because it is still to 3 significant figures. Do you see how on each of these we've added this kind of 0.05? We'll do the same for the s as well. So the upper bound would actually be 45.05, and the lower bound is 44.95. So just be really careful with that one. Now to just sub it all in. So for the upper bound of a, that would give me 1.5319. Write down a few decimals. And do the same for the lower bound. As you can see, that gives me 1.459. So finally, I need to decide on how to round those answers to give me just a single answer. So you just check them and say, well, what do they round to? It could end up being a few different significant figures. It could be the nearest whole number. It could be a number of decimal places. It just depends. In this case, they both would round to 1.5, wouldn't they? So I would say a is 1.5. And then our reason is some version of this sentence, right? In this case, to 2 significant figures, or technically you could say to 1 decimal place. That's also the same thing. They both round to 1.5. So some version of when we round them to this thing, so in this case 2 significant figures, they both agree, they both end up being that answer. So that's why you're trying to figure out, if I look at my numbers, what do they both round to? That's my reason, because they both round to 1.5 when I've got 2 significant figures, or even, as I said, 1 decimal place could also work. And as you can see, that question is normally a 5 marker. So that is everything for my predicted paper 3 for Edexcel higher tier students. As I said, you can check out my paper 1 and paper 2 predicted papers as well for any of the topics that actually didn't come up in your exams. There's questions there that might still be useful for your revision. I've also, as I said, I'm going to repeat myself with a disclaimer. Please do not use this paper as your only revision. Please do not assume that these are the only topics that will come up, because technically any topics could come up, right? I'm just making a prediction, but it could really be anything. So make sure that you are still doing wider revision on the whole syllabus for maths for your paper 3. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.